Good evening, Nano fam. Hello, welcome to this next episode of the development stream. Oh, the chat is busy. Let's see. How are you guys? So, Nano is the light, Wenderson. I love that. I love that saying now so much. Nano is the light. AAK says, guys, can we sign a petition for Gustav to maybe change the background music of his streams? Yeah, so the thing is, I like background music, and in order to have background music, you have to pick music without copyright. And I don't have a lot of music without copyright. I just use a playlist from Google Music that is from no copyright sounds. And I would love to play different music. But yeah, this copyright restriction makes it just very difficult to pick music that I like. So, hello guys, hello LF, hello Sergio, hello Andifnal. So let me add you. I hope it's okay for you. I add you to the wheel, to the spinner wheel. So we have. Where do I start? AAK, dude, are you in the address book? No, you're not. So if you want to take part, just post your Nano address. But we have Andifnal. We have LF. And Sergio, I think you're in the address book. Yes. And that's 3 already. Yeah. Okay. Yeah, so if you want to take part in the Nano giveaway, just post your Nano addresses in chat. So Andifnal says the music is fine. Yeah, so chat, if you prefer no music or music, just write it in chat. Yeah, so post your Nano addresses in chat, and we are going to start the Bitcoin block countdown right now. And after 10 minutes, after Bitcoin manages to produce a single block, we are going to give away 1 Nano. So I received a 13.3 Nano donation just before the stream started. So thanks so much for that donation. So I am increasing the giveaway from 5 Nano to 10 Nano. So we are going to give away 1 Nano every 10 minutes. Yeah, so countdown running already. Okay, so we have, let me just switch the screen here. So we have more Nano addresses. So let's add a new entry here for AAK. And your Nano address. That the right one? Yeah. And also added you to the spinner wheel. Okay. So today was another Nano developer meeting on Twitter. So that's the second public developer meeting. And I couldn't join, unfortunately, because today is a holiday in Germany. And we went on a family trip, and I just couldn't. I wasn't home early enough for the developer meeting, and I haven't listened to it myself, but I'm going to do that right tomorrow morning. So yeah, I really like the more public developer meetings now. Have you guys listened? Let me know. AAK says family comes first. Yeah, so it's especially if it's a holiday. Yeah, we went to the zoo. Okay, so RS Nano, we are porting Nano to Rust. Last time, and on the last stream, we worked on the TcpStream, and we made the TcpStream nullable. LFLF says, was there any announcement? I missed it again. I don't think there was an announcement. So it was the same time as last week. I think 4 p.m. German time. That is, what's UTC time? 2 p.m. UTC, I guess. And No, there was not an announcement. It's on Colin's Twitter. Okay, so yeah, so last time we worked on the TcpStream, and we wanted, or I wanted to make it nullable. And nullable means, so this is all from the James Shore article, blog article here. Let me open it up. Testing without mocks, a pattern language. I have recommended this like many times now on the stream, and it's a technique to test infrastructure code by making it nullable, and nullable means we can just switch it off. And we did that on the last stream. So we wrote a wrapper class, and that was our stream. So I made this box green here, our stream, and it just delegates to the real Tokyo TcpStream, or it delegates to an embedded stub. And in that way, we can use our TcpStream now in tests without having to use real sockets. And the whole plan is that we simplify our message deserializer, this box here, which reads bytes from the network, and it converts those bytes into messages that we can process further down the road. And it is very ugly. Currently it uses this monster of a callback that I wrote out here, a real monster of a callback, and I want to get rid of that. So that's the long-term goal, which we are going to work on for the next couple of streams. And so that is the goal, to get rid of this monster callback and to just use async Rust code instead. So last stream we finished the nullability of our TcpStream, the nullability of the reading part, I have to say. So the writing to the TcpStream, we have not implemented that yet, and I'm guessing that we're going to have to do this today, because we are going to work our way backwards. So right now we are here at this green box, and we want to, it's not being used right now. We just wrote it and no one uses it yet. So let me just add a new Nano address here for our giveaway before the timer goes down. New entry, and save. Oh, we have that name already in the. Is that the same address? Yeah, it's the same address. So just adding you to the spinner. Okay. Yes. So the plan is to work our way backwards. Currently, when we read bytes from the network, it goes from the TCP channel class to the socket class, which goes to the TCP socket facade trait, which has like the real implementation and the null implementation, and that goes to the Tokyo TcpStream. And that is just, that's just way too complicated. Too many parts. And I want to refactor this now and simplify it. And I want to do this in very small and very simple steps, because that's the way I like to work. If you go in small and simple steps, you don't get yourself into trouble and you have a relaxed workday. So the first step would be that we actually use our new TcpStream class. And for that, we have to point our Tokyo socket facade, which directly works with the Tokyo TcpStream, to our implementation, like that. Okay? So let me just maybe put it like that. Okay? So that would be the first step. And this is what we are going to do today. Just this step. And maybe let's paint the picture for the future. So once we have our TCP stream in there, and we want to do this so that we can test those classes, because with our TCP stream we can switch it off, it is nullable. So that means we can easily write unit tests for all of those classes here. So the next step would be to get rid of the null socket facade, because that one is not needed anymore because our TCP stream is nullable. So we can just use a nulled TCP stream with the real Tokyo socket facade. And so once this one is gone, we can get rid of the trait, because we just have one implementation, the socket Tokyo socket facade. And with only one implementation, it doesn't make sense to have a trait, really. So let's get rid of the trait then. And then the next step is to get rid of the Tokyo socket facade completely, because we don't need a Tokyo socket facade. The only reason we have that right now was so that we could port the code from C++ to Rust in small steps. But we are done with that, and so that facade doesn't make sense really. And we can just directly use our TCP stream instead of a facade class, because our TCP stream is testable. Yeah, so those things, they will be deleted. And then the next step would be the socket. And I don't even think we would need... I don't even think this abstraction is really needed. Because the only I think it just manages some timeouts. And maybe we can move that responsibility into our channel class, and then we could even get rid of the socket. So a lot of code being deleted in the future. And as you see, oh, time is over. Bitcoin finally made a block. Let's start the spinner. Oh no, stop. Wenderson. No. So this will be, no. This will not be the one, because I forgot to add Wenderson. Sorry, this is not the thing. Let's just add Wenderson quickly. Wenderson. And are you in my address book? No. So let's add you. Nano is the light. Okay. So now let's spin it. One Nano. Two. Underflow. Let's go. Okay. Walk. There we go. Okay. So that is the plan, to delete all of those classes. All of those structs. Rust doesn't have classes. Yeah, congrats, LFLF says. And then the code will be just simpler. Simpler than right now. And LFLF says, and must be rich by now, rigged game. And LFLF says, oh, by the way, I suggested my team at work to write tests first. We are already late, but we can afford a slight delay in this phase. I know it will pay off later. Oh, great. Yeah. I've worked with teams and I've suggested the same. And so my experience was that it was always like a lot of skepticism. But if you start with the tests and you actually have experience with writing tests, then this is just a great idea. because for longer running projects, it doesn't make much sense if the project is small, really, because the payoff is if the project grows and you have to refactor, and with refactoring without tests is just very painful. Yeah, so let me know how it goes. So yeah, so where was I? So that's the plan. Getting rid of all of the red boxes and just directly using our green box, our TcpStream, just directly, and not having those all of those abstractions in between. Okay, so but for today, our goal is once again to. So let me just remove those colors so that we can focus on what we are going to do today. Our goal for today is to remove this arrow. Can we make that red? Yeah, so red means we are going to remove that arrow, and we are going to introduce the green arrow. So that is the thing we are going to work on today. Switching out the Tokyo TcpStream by our TcpStream, which uses the Tokyo TcpStream, but it is nullable. Okay, let's go to NeoVim. In order to switch out the stream in the TCP socket facade, we have to find where it's used. So Tokyo socket facade, that is the struct, and it has a state, and the state is an enum, as you can see here, which is closed connecting client and server. And that really doesn't make much sense. It just grew that way when I ported the code from C++ to Rust. So the original meaning of our facade was that it was the only class that was allowed to talk to the async runtime. And all of the calls that had to go to the async runtime had to go through this facade class. And I made it like that so that in the end I just have to port a single class from C++ to Rust to bring the async runtime to Rust, to switch to the Tokyo async runtime. And that's why we have this facade right now. And that's why it has two modes, the client mode and the server mode. The server mode uses a TCP listener, so we don't have to worry about that right now. But the client mode uses the Tokyo TcpStream. And the first thing I want to try is I want to remove the import of the Tokyo TcpStream and instead use our TcpStream. Let's use the autocomplete. And let's see how many errors we get. So we have 2 errors in here. So yeah, so that is could not find TcpStream. So now let's import our TcpStream. Okay. And let's see how many errors we have. Still just two errors. We have one here. It says cannot be shared between threads safely. What cannot be shared between threads safely? Oh, is that a requirement? So our internal TcpStream is not send, or cannot send. It's not. Does it need to be send and sync? Let's have a look. Yeah, send and sync. Now that's unfortunate. It has to be send and sync. So the send part makes sense. I guess why did I add the sync part, really? Why did I add the sync part? Can we remove that? Probably not, because maybe from it will have access from multiple threads at once. I want to try what happens when I remove it. So I want to go back to the Tokyo TCP stream. So let's can we use comments in here? Yeah. So let's use Tokyo Net TCP stream again, so that we don't have errors anymore. And I just want to try to remove the sync part. Will this cause errors? Let's go to the Rust folder and let's do cargo check. Yeah, there are errors. Because channel TCP observer. I had to add a lot of send and sync stuff to make it work with the C++ code, and so let's re-add the sync part. So we have to make our TCP stream sync. The problem is just that it isn't sync. So sync means that multiple threads can access that an instance at the same time, basically, and it would be synchronized. So it would use something like a mutex or a reader or writer lock or atomics or whatever. But really our TCP stream is not designed to be accessed from multiple threads concurrently. So it really doesn't have to be sync. Another giveaway, guys. No more addresses? Oh, there are addresses. One. So we have Niyush. I think you are in the address book. Let me check. Yes, you are with the correct address. Yeah. So who else? Croucher, hey. Might be the ARC reference. Let's just do the giveaway and let's go back to the problem. Yeah, so I added all of that send and sync stuff just to make it work with C++, and that is just unsafe, and the game is rigged. End of null. The game is rigged. End of null. One Nano. Yeah, it must be rigged. So there you go. Congrats again, says Sergio. Okay. So I could do something dirty and just mark our yeah, I think I'm gonna go that way. So this is a temporary fix. The temporary fixes, I'm going to mark our TCP stream as sync and send and sync. It uses. Let me just. Can I just quickly check if the Tokyo TCP stream is send and sync? trait implementations. It is. Oh, it is send and sync. Oh, I thought. Okay. Yeah, well, if it is send and sync, was that a subscriber? Yeah. AKA. Oh, it's gone already. Thanks very much for the subscription. Okie dokie. So. Yeah, it is send and it is sync. So I think we just need to add the send and sync stuff to our trait that we introduced last stream, the internal TcpStream. So if we say this must be send and sync, maybe that fixes it already. Let's do a cargo check again. Yeah, it finished. So let's go back to... So let me just reiterate. Send means the instance can be moved from one thread to another thread. And sync means the instance can be accessed from multiple threads concurrently. Yeah, so I think that was it. So let's go back and deactivate the Tokyo TcpStream. And let's reactivate our TcpStream. And yeah, now we have different errors. And the errors are missing methods. And that is okay because we don't have those methods yet on our TcpStream. So yeah, we just have to add them. So that is local address, connect, writable, try write, and so on and so on. So let's do that one method at a time. So let's start with local address. Local address. Oh, let me just do a split view here. And let's go to TcpStream. And let's add some comments here of functions that we need to write. So here's the TcpStream. So right now it basically just has readable and try read, but we need local address. We need connect. We need, what else do we need? We need writable and try write. And what's the last ones? Yeah, so this is not an error. A real one. That is peer address. Local address and peer address. Okay, so that's all of the functions that we have to add. AAK says Undev gets all the broccoli. Crouches as I see async trait derived here. Yeah, I'm doing some funky stuff with a pinned box future as my return type to get around the no async in traits issue. But you have no issue with the crate. Yeah, so I introduced the async trait last stream, and I said it would be a workaround for, or a temporary solution, because yeah, in the async trait crate, it uses heap allocations to get around limitations in the Rust compiler, and async real async traits will be stabilized in the near future, and once we have stable real async traits, I want to get rid of the async trait crate, and then we can use async traits that are not heap allocating. So that should boost performance a little bit. So the solution right now is a little bit imperformant, but I think it won't matter at all, because our bottlenecks that we have, they are not related to heap allocations. So they are more like voting, network messages stuff, and or disk lookups in the ledger. So having more heap allocations in the networking part right now is not an issue at all. Like, really not an issue. And we are going to fix that once real async trades are stable. Croucher says, that's cool. LF says, async trade crate is quite popular and I've also used it without a problem already. Maybe just give it a try, Croucher. Yeah, so I've used it in the past before, and also I didn't have a problem with it. But I have to say I haven't written like really complex stuff with it. It's just very simple networking code. Oh, have I restarted the timer? No, I haven't. So, a Bitcoin block timer running again. Okay, so let's oh, that was the wrong one. Let's go back to Tokyo. So I want to remove the errors. So we should be error free now. Yes, we are. And now I want to implement the missing functions in our TcpStream. So that is local address. So local address, and how does local address look? What does it do? It returns the local socket address. Where is it? Here it is. So it just returns a result of socket address. And result is std.io result. So this returns result of a socket address. And what I want to do right now is I don't want to implement the nullability right now because we don't need it yet. So let's just write code that just does a pass through. So like up here we are going to say self.stream.local address, and now we have to add it to our internal TcpStream trait. Like that. Oh, sorry. First I have to add it to the trait, like that. And then we have to implement it in... What's wrong here? Local address from trait. fn local address. Oh no, we have to implement... Sorry, I was confused by the message. We have to implement it down here, and I'm just going to pass that through to the real Tokyo TcpStream like that. So there's no magic here. So this is just a very dumb pass through, and I don't like code like that, but this is just so that we can use a trait for our stream, so that we can replace it with a stub. This one is the embedded stub. And here I'm going to... Oh, there's no code completion? Oh. Then let's copy. Then let's copy from up here. So local address, and here I'm just going to say to do. And this will panic if we call it, so that we don't forget to implement that one. Local address. And as you have noticed, I have not done that test driven, and this is... So a purist TTDealer would even write tests for that. But here's the thing. The code I just wrote, it doesn't do anything. It just calls the same function on another object. And really, what could go wrong there? So, yeah, so I did that in a bit of a dirty style, but I really don't see a reason for this to go wrong. So the next one is peer address, which gives us the socket address of the remote. So this also, my guess is it also returns an I/O result of socket address. Oh, another follower, Croucher, thank you. So our people from Twitch, yeah. So we have 8 viewers in total, 5 on YouTube, 3 on Twitch. More Twitch viewers than usual. So, are you you Twitch guys? Are you Nano fans, or did you just stumble upon the stream? So TcpStream peer address. It just a result socket address. So just the same. A result socket address. And we just call the same peer address. Croucher says, I saw NeoVim and Rust and clicked. That could be me. so me switching to NeoVim already had an impact, because I switched back to switched to NeoVim only a couple of streams ago. Yeah, so Croucher, let me just give you a very, very short intro to what we're doing here. We are working on this project, RS Nano. rsnano.com is the website. And if you are interested in what we do, you can just visit rsnano.com and you find everything explained and links to the source code and to our Discord server. And this is the progress so far. So I've been working on porting the Nano node, which is written in C++, to Rust. And I've managed to port, it's not just me alone, I have had some help, roughly 40%. And I think it's even really more, because my way of measuring the progress is pessimistic, I would say. Yeah, so you can find everything here. Croucher says, switched to NeoVim about 3 months ago and never looked back. Yeah, so I actually used Vim in the past very much. And then I had a couple of years where I didn't use Vim. And now I'm back at with NeoVim and I'm really happy. Croucher says, cool, keen to see how it progresses. Yeah. So the goal is, of course, to have the full node in Rust and with async Rust, really. And also the goal is to refactor the code to make it more modular and simpler and so on. So that's what we work on here. And currently, so just like, I don't know, 3 weeks ago, I managed to switch the async runtime from C++ Boost to Rust plus Tokyo. And that's why we work on this socket TCP stuff right now. I want to use the async way of Rust to do the networking module, really. And that's why we refactor this here. AIK says maybe code Nano in Nano text editor. Yeah, but I've never really used Nano. And I think it's quite a limited editor. Yeah, so peer address. We have to add peer address to our internal TcpStream. Here we go. And we also have to add it to our Tokyo TcpStream wrapper. And here again, we are just going to pass the call to the real stream. Nothing fancy going on here. And in our stub, in our internal embedded stub, we just say to do, and we implement it when we need it. That's also something in software development is Yagni. Do you know the principle Yagni? you aren't going to need it. You aren't gonna need it. Because that's just something we all do. We implement stuff where we think we are going to need it, and then we put a lot of effort in it, and we are not needing it then. So all of that effort was wasted. So I don't like to waste time. So I usually wait until I really need something before I implement it. So that's peer address. The next one is connect. Oh, connect is, we have to skip that because that's a special case. Let's put that to the end. So we have to use port writable and try write. So writable, fn writable. And this is, oh, this is an async function because it waits until the stream is writable and it returns. What does writable return? Oh, giveaway time. No more nano addresses, so let's spin the wheel. If it's under null again, I don't know what to do. No, it is. Oh, that name, yeah. I don't know how to pronounce, but congratulations for 1 nano. There you go. Back to, oh, restart the block timer. Okay. Yeah, writable. I wanted to look what writable returns. Just an empty result. Just an empty one. And so that's writable. So that means in our real implementation, we also pass this just through to the actual TcpStream. And in our stub, we say to do. Like that. What else? So try write is the next one. So we have try write. And what else does try write need? So we are going to have to make all of those try write and writable functions nullable in the future. Pretty sure, but I'm not going to work on that right now. So this just takes a, let's just copy that. Just a buff or yeah, buff. It is buff mute. No, not mute. Just a byte slice, and it returns Tokyo IO result usize. And I think usize is the amount of bytes that were actually written. So let's implement it in the real one. Self.0.try_write. And in this internal embedded stub, we say to do. So, okay. That's it. Those are the missing functions. Crouches says, yeah, this is the madness I'm doing to get around async trade. Pin box, din future, output anyhow result, vec self plus send with self sized and send. Wow. Yeah, so Rust, it has the tendency, like, so if you have to actually write out those types, they can get nasty. So really ugly stuff. And also, I don't know if you saw the stream from the beginning. So this is basically the long-term goal for the next couple of streams, is to simplify the struct message deserializer. And this one uses a callback right now. And this is the callback. Can you see it? A boxed in fn arc mutex evacuates. It's just a horrible, horrible piece of code. And I want to, yeah, just use a simple await function instead of having that monster of a callback here. Croucher says, love it. Yeah. Are you? So this is just really bad code. I'm happy that you can enjoy bad code. And we all write bad code from time to time. And when I wrote that code, I knew it was really bad. And I also knew that I would remove it as soon as I can. So now is the time to remove that bad code. And but we have to jump through some hoops first. We have to use our green box, here it is, our TcpStream first in those classes here. And then we can refactor this monster callback away and just use a simple async function. So we have added the missing functions, and except for connect. Oh, we have to add it down here too. Local address, peer address. There's some they are missing down there. So we have writable and try write. Internalities here, TcpStream trait. So self.stream.writable. Await, and try write is also self.stream. Try write. Try write buff. Yeah. Okay. So the only function that we haven't added here is connect, and connect is a special case because it is static. So we can't just add it here. We have to introduce a factory struct. We have to introduce a factory struct because we want to make this factory also nullable so that we can create new TCP streams that are switched off. So that's why we can't use a static connect function here. Wenderson says, exists beauty in simplicity. Yes, so I think you want to say that simplicity is beautiful or something like that, and I would fully agree. So so in software development, we create horrible complex monsters sometime, or especially if we start as a young programmer, we create a mess of code really, and then maybe there comes the phase where you can handle the complexity, and you get addicted to complexity, and you get proud of being able to work with complexity. And that's a very dangerous phase, because basically complexity is yeah, it is a monster. So you stay away from complexity really. And then there comes this very long phase, from my experience as a software developer, where you lose interest in complexity, and you just see how valuable and how beautiful simplicity really is, and then you try to write code that is simple. And that's the phase I'm in. Well, I've been in for a while now. So where I just think of how can I make this more simpler, and how can I stay away from complexity. And this also is it affects libraries, for example. How quick are we developers to jump to whatever library and just to introduce like a lot of complexity just by jumping to a database, for example, directly to a MySQL, whatever, PostgreSQL, how do you pronounce it, whatever, MongoDB, whatever. We jump to databases, and maybe the simplest thing that would work is writing it to a file. Yeah, so simplicity is really important. And if now says it's not that easy to write simple code. Yeah, that is so true. So writing simple code is really hard most of the time. So that's the funny thing. You look at the code and it looks simple, and you say, oh, that was simple. What a simple piece. And writing simple code, that's not simple at all. Okay. Yeah, so the connect, we have to, before we can move on, we have to find a solution for the connect function. So let's see how it is used. How it is being used in our TcpStream, TCP facade. So there must be some place where we call connect. Here it is. Here it is. Yes. And just did a code search if there are more places. There are more places, but just one in the TcpStream RS. Yeah, no. So this is the only place. Okay. So this is the only place where we call the connect function. So, and I want to write something like, I don't want to say TcpStream connect. I want to write something like TcpStream factory connect. And basically the same thing. No? Giveaway. No more Nano addresses. So if you want to take part in the next giveaway, write your Nano address in chat and you can win 1 Nano. One Nano. This is so rigged. This is so rigged. Undef null again. Undef null. 1 Nano. Okay. Level says no way Undef, congrats. Yeah, I'm getting doubtful of this wheel. Just Google for a wheel and I just picked that one. Okay, so TcpStream factory connect. I want to write something like that. TcpStream factory, and then later we can make this TcpStream factory nullable. And then we can write unit tests that create that test code that creates TCP streams without using real TCP streams. So yeah, I think let's introduce a TCP stream factory, and that returns our TCP stream. Yeah, let's do that. So let's go to TCP stream and let's add a test, or let's modify this test. We have a test that connects to a real TCP server, so that's one. That's the test. Connects to real TCP to real server, and it starts a real server, and then it creates here. It uses the Tokyo TCP Stream Connect to connect, and I want to write this in a different way. I want to say let stream equal to, so we need the TCP stream factory. So TCP stream factory. And then I want to say stream factory connect. Basically, I want to say like it does up here. So I want to do this, and this would return our TCP stream. And then we could get rid of this. Make sense? So let's do that. Let's create a struct TcpStream factory. Or should we call this TCP connector? I don't know. We can rename it anytime. So what is the function signature for connect? For the Tokyo connect function. Can we jump there? No? Can't. Let's go here and look. TcpStream connect. It is an async. Let's copy that. Copy. And paste. So this is a Tokyo IO result. Maybe. And pop async fn connect, and it takes a 2. It takes a 2 socket addresses. It takes the address here and returns that. Okay. Oh, what did oh my god. It's so stupid. I have to add an impl. Oh yeah, I was just confused. I have to write an impl here. TcpStream factory. Like that. Yeah, that's the price you pay when you work in multiple programming languages. You just get confused from time to time. So, the 2 socket addresses, we have to import this. Import, yeah, stdnet or Tokyo. Does that make a difference? Okay, and here so this has to be nullable in the future, but I don't want to focus on that right now. We can do this on another stream. So what I want to do now is I want to just copy the code out of the test and move it here. Let's delete that. And let's uncomment that. And let's return the stream. So what that does, it calls the connect on the Tokyo TcpStream. Oh no, there's an unwrap here. We don't need an unwrap here. So like that. So it would return the error. And what? Oh yeah, so we have to return. Oh, we have to wrap this in. Okay. And oh yeah, we have to use the address. And let's add a new function. Okay, so that's it basically. So let's run the tests and see if they are still green. So let's hope that this still runs. And now we can use that factory. Oh, use of undeclared creator module stream factory. We have a problem here. Here, stream factory. Oh yeah, because it's not a static function. This is now a normal function. And now this we have to unwrap, right? And await. Yeah. Use associated function syntax instead. Oh, I think it's still an associated function. Yeah. So we have to add self here. Like that. That's the whole point of why we're doing that. So the whole point is that we can make the TcpStream factory nullable, and we can make it so that it returns nulled TCP streams instead of real ones. So now all errors are gone. Let's try to run the tests and see if they are still green. Yes, they are. Good. So that means we can now use that one in our list. So let's go back to our overview of what we are working on. So our goal is to remove the arrow that is red and replace it by the arrow that is green. So we want to use the Tokyo socket facade to use our TcpStream class instead of the Tokyo TcpStream. And right now we've added another struct. So let's just add it here. And this one we called TcpStream factory. And let's make it green. So this is also new. And we have to give that one to our Tokyo socket facade too. So that is the plan. Adding those two dependencies here, and then removing that dependency, that dependency, the red arrow. Okay. So let's do that now. Let's go to Tokyo. Oh, another giveaway, guys! Another giveaway. Let's just restart the timer. Spinner wheel. Will it be under null? Chat, what do you think? Will it be under null? No, it's LF, so the game isn't rigged. The game isn't rigged. Let's go here and LF. 1 nano. There you go. We gave away 5 nanos already. So socket. Our TcpStream. Our TcpStream has to be used in the Tokyo socket facade. So let's enable our TcpStream, and let's disable the Tokyo TcpStream. And now we should have a couple of errors, and we do. So that's the first error we see. LF says it isn't under if the game is rigged. Okay, guys, there's no way there's no way I can convince you that the game isn't rigged. So post your Nano addresses in chat if you want to take part. So yeah, so that's the place where we have to use our factory. So the first step is to add our factory to our Tokyo socket facade. So TcpStream factory is TcpStream factory. And we are missing the field TcpStream factory. So for now, I want to just instantiate it here. Like that. And in the future, this yeah, let's not think about too much of the future, because in the future this whole struct Tokyo socket facade will be deleted anyway. So the plan is just right now to use our implementations so that we can null them and use that in tests. And we want to go in small and simple steps. So we have added the stream factory. So now we can call it here by saying, oh, this is in a spawn call. Do we have access to self in here? And we say self dot TcpStream factory dot connect. Yeah, so I don't see an error, so that's good. Now it says that writable is private. Oh, I forgot to make all of those functions public. Oh no, this one is public. Okay, just one error left, and that is here. Arguments, what is the stream? Where does the stream come from? Oh. Let's just jump to the error again. It comes from... Oh, okay, listener accept. So maybe we can just cheat a bit here and just push that stream into our stream. Because this is a Tokyo stream. A Tokyo TCP stream. So let's say let's stream TCP stream new. So this is our stream. And let's just add a comment here. Wrap the Tokyo stream in our stream. So that we know. So this is just a hacky way right now to get everything to compile. So first make it work, then make it nice, and then make it fast. Borrowed data escapes outside of method argument requires that. Okay, we have a lifetime issue here. And the lifetime issue is our self. Our self is borrowed data. So we can't do that. We can't. That's bad. How else can we write that? What is this one? This is an arc. Do we have to put our TcpStream factory in an arc? Oh, that would be ugly. Probably. Chat, do you have an idea? So the arc thing would work, but it would be bad. Just slapping arcs on it is just like a very lazy way of solving the compiler issues, and it's just not very idiomatic. But I think I'm going to do that because I want to get it to work, even if it's ugly. And then I want to optimize later when I have something that runs. So Stream, it's your chance to stop me from introducing an arc. Yeah, I'm really baffled that we have 4 viewers on Twitch, because usually all people watch from YouTube. And today we have Twitch viewers. arc. Yeah, let's put it in an arc. Oh, I don't like that. But it's... I hope I can get rid of the arc again. So... Oh, what am I doing? Arc... It's just... Arc new. So arc is, for all of you non-Rust guys, arc is an atomic reference count. So this is the same as a shared pointer in C++. So this as a reference counter that is atomic, so you can access it from multiple threads. And as soon as the last reference is dropped, the whole thing goes out of scope. So now then we have to say let socket factory stream TcpStream factory is an arc clone. So here we create a clone. So this is increasing the reference count for our TcpStream factory. And then we can use that one in our async code down there. And this, yeah, so this solves the issue. And if not, says, where are the rustations when you need them? Yeah, but there are surprisingly many in this stream. Yeah, this arc stuff is bad. But let's hope to get rid of it in the future, because all of that code that is ugly anyways, like look at this huge function. I don't like functions that are that huge at all. And all of that code will be deleted pretty soon. So don't worry, guys. We got it. Yeah, so... Oh, no more complaints from the compiler. Giveaway. So I think we are there. 1 Nano 2. LFLF again. One Nano to you. Confirmed instantly. And let's restart the Bitcoin block timer. 10 minutes for a Bitcoin block and instant confirmation with Nano. AAK, the game is rigged. Yeah, you still have chances. We have, how many nanos do we have? 4 more nanos to give away. So there is still a chance to get one. Okay, we have no more errors anymore, and the tests are still green. Let's run the tests. And while that one compiles, let's think about what we can do next. LFLF says, thanks, sorry to steal your streak. What can we do next? We have our TcpStream now in. Let's have a look at the diagram. So, oh, the test passed. Good. So we got rid of that dependency, the red arrow. So let's remove that. And now it looks like, oh, you can't see because there's the chat overlay. So now it looks like that. And the next step would be to actually make the TcpStream factory nullable and to actually make the writable stuff of the TcpStream nullable, maybe. And then to remove... Maybe we can try that one first. Maybe we can try to remove the null socket facade because I've looked at the usages and I saw that there's only one usage. Maybe we can start here and get rid of this. And then we could, and as a next step, we can get rid of this trait just to simplify the code a bit. Null socket facade. Maybe, let's see. Let's go to, or I want to commit this first. Yeah. Let's commit this first. Use our TcpStream in Tokyo. What was the name? Tokyo socket facade. Push. Okay. And then what did I just say was the plan? Oh yeah, the null socket facade. We want to remove the null socket facade. So this is the TCP socket facade trait. Oh, I wanted to search for implementations. Here they are. And there is the null socket TCP socket facade. And let's search the usages. And there is only one usage. And this is the one usage. It's the create null function in socket. And I think this is only being used in one test. Yes. So there's one test that uses it. And this is the test, count subnetwork connections in server socket. And I think it just needs... What does it need? So it just needs a socket that doesn't do anything. This is not... That socket is not really used. So it just gets a remote address set here. And then it's inserted into a connections. What is this? Connections per address. So whatever. So basically this just creates a socket that we will not use at all. So we can rewrite this create null function, and it should not use the null TCP socket facade, but it should use the real TCP socket facade, but as a null instance. So like that, create null. And there is no create null function right now in TCP socket facade. So let's create one. Oh, why did it jump to the trade? No, socket create null. TCP socket. No, not TCP socket facade, because this is the trade. We have to call Tokyo socket. Oops, Tokyo socket facade. Wait, no. Tokyo socket facade. And let's create a create null function. And this should return self. Oh, what does it have here? Runtime. Oh, it needs a async runtime. Do we have access to? Yeah, we... No. Why do we need an async runtime? Yeah, for calling spawn and stuff. Yeah, so that's a problem. We need an async runtime. Um, So let me refactor that. I don't like this code duplication. Who calls this new? Not many places. The only difference in those two calls, in the new call and the create null call, is the TcpStream factory. Because in this one we want to also use a nulled one. So yeah, let's leave it like that for now. How can we call the new function from the create null function? Current action. Yeah, let's call the new function from the create null function. And let's give it the arc TcpStream factory create null. And then we add it up here. That is the TcpStream factory, which is an arc TcpStream factory. And then we just add a create function that will be used by our production code, which just takes the async runtime, and it will create an instance with the real TcpStream factory. Like that. Yeah. So this looks good. Just have to adjust usages now to use the new create. The new create function. Oh, did I restart the clock? Oh yeah, 3, 2, 1. Finally, Bitcoin got a new block. Let's restart the block timer. 1 new block for Bitcoin, many blocks for Nano. Is this real? Now it's LF getting all of the nanos. So, okay. So we remove the duplication here. Yeah, I want to just fix the call to create so that we don't have compiler errors here. And here too. Okay. So let's have a look at the errors. LF says, the game is rigged for real. Thank you so much. So yeah, I'm getting suspicious too, that the wheel must be rigged. Yes, maybe we should have investigated the code. Yeah, let's wait and see what happens. We still have 3 more giveaways. 3 more. And how late is it? Yeah, that's okay, because I want to stop in 30 minutes. So So let's continue. So the create null. Yeah, the TcpStream factory needs a create null function. So let's add a create null function here. Create null. And this one. Create null. Must return. Oh. Now we have to make it nullable. Let's say to do. I want to see the test fail first, so I don't want to implement anything here. Let's just say to do. I want to get it to compile. Okay, we have a problem in socket RS. Socket RS down there. Yeah, so this create null needs an async runtime. Maybe can I add it to the create null as an argument? Do we have an async runtime in this test? Oh, we don't. That's bad. We don't need a async runtime when I think about it, because our... Or do we? Yeah, we do. LFLF says, doesn't go create null with arguments go against the concept of nullables? No. So yeah, so usually you should have a create null function that doesn't take any arguments, so that you can very easily create an instance for in your tests. But if you want to add test data, that's totally fine to have arguments in there. Yeah, okay, now I can see your point, because that the runtime isn't test data. Yeah. Yeah, but basically the create null is a constructor that creates a nulled instance, and our Tokyo socket facade, it needs an async runtime, and I can't create one here. Can I? Should I? Could also try to create my own async runtime. But that's just, yeah, an expensive thing. Should I create my own async runtime? Or can we... Yeah, I see that that runtime is being used in many places right now. And here where's the usage? Here's the usage. And here we don't have an async runtime. LFLF says, I would expect that create null construct every dependencies itself. But I get your point. Yeah, and I get your point. Yeah. Should we create the async runtime? So maybe we can do that. LFLF, good point. Good point, LFLF. Maybe we can do that, because right now it is only being used in a single test, and that test doesn't need an async runtime at all. So it doesn't really matter what we do with the async runtime. So maybe we can just create our own. And it needs a Tokyo runtime. How to create the Tokyo runtime? Tokyo runtime. Okay. Okay. Where was it? Here. So if we say Tokyo runtime, can we do it without the builder? No, runtime, builder. New, current thread, build. That? Yeah. So let's cargo check again. Oh. Socket RN FI socket RS. Socket RS. There's something wrong. Yeah. No. Tokyo socket facade. What's the problem? The error is this function takes 2 arguments, but 1 argument was supplied. Oh, I didn't save the file. That was the problem. Okay. Yeah. No more errors. A couple of warnings. That's okay. I can fix them later. Okay. So now we have a create null. And that create null is being used in this, where is it? In the create null of the socket. Yeah, let's see if the tests are still green. Because if the tests are still green, we can delete the null. What was the name? If the tests are green, we can get rid of the null socket facade, and we can also delete the trait. Isn't that nice? Guys, I love deleting code. It's just as much fun as writing code, maybe even more. Deleting code is such a nice feeling. Oh, we have a test failure. Not yet implemented. And where does the failure come from? Let's spin the wheel. First, finally, Bitcoin created another block, and we can send one Nano instantly. So, congratulations for Nano. And send. And restart the timer. So. And Evnar says, congrats, LF, your streak was broken. Yeah, but I'm still suspicious of this wheel, so I'm not totally convinced yet. So what was not implemented? Not yet implemented TcpStream 167. Line 167. So the create null of TcpStream factory. Okay, so that is something we have to implement before we can commit. So we have to have a create null for the TcpStream factory. I think I want to put this in its own file, just so that I have a better organization of the tests. Because otherwise I would mix the TcpStream tests with the TcpStream factory tests. So yeah, let's create a new file, a new module, and let's call that TcpStream factory. And I want to create the file. And then we can just copy that, just delete it here, and move it here. So we have to import a couple of missing imports. That looks better now, and here we have unused imports. Okay. Okay. So now we can add some tests. So let's see, test, tests. Super. We want to import super. Everything from above. Oh, sorry. And now we can write a test. And that test is called... yeah, can be nulled. And in this test we call TcpStream factory create null. Oh. And this should not fail. And currently it fails with a to-do panic. And then we want to call connect. And the address really doesn't matter. Port 1. And just which port number, 42. It really doesn't matter. So this should... It should fail. So we say, oh, wait, so this has to be a Tokyo test. Expect error. Connect should fail. Ed, hey, welcome back. Hey all, oh, I missed stream, so sorry. Yeah, no problem. You can still post your Nano address and take part. Oh, or Ed, I think you are in the address book. Let's see. Yeah, there you are. So let's add you to the wheel. And you can rewatch the stream on YouTube, so no problem. So yeah, so we call connect and it should return an error, and then let's assert on the error here later. But I just want to start here. So let's run our watch test script, which reruns the tests after every file save. SocketRS has a problem. What? Unresolved import. TcpStream factory. Oh yeah, we moved the TcpStream factory. Let's go to the mod and say, yeah, I don't want to have this in its. I want to use the TcpStream factory here, and I also want to use the TcpStream here. No, it doesn't make sense to have its own namespace for all of that. Ed says, yes, we'll rewatch it. Thanks for being here. Thank you for being here. So it's TcpStream factory. Now we can import TcpStream factory and no more errors. So let's wait for the tests. So now we should own another error in TcpStream RS. TcpStream RS. Failed to resolve. Yeah, so also we have to import TcpStream. And TcpStream factory RS has a problem. Here, the async keyword is missing. Yeah, so we have to add async to our test because it is async and doesn't implement debug for trade debug. Okay. TcpStream doesn't implement debug for the trade debug. Really? Ah, okay, because... Yeah, then let's write this in a different way. Match. And... Oops. And this returns... If this returns an okay, we say panic. Connect should fail. And if it returns error, we can assert on the error. So assert what is e error e dot kind is equal to error kind other. Import this, please. Yeah. Error kind other, and we also assert that e dot. What does it have? Error kind get ref into. Oh yeah, so the toString is equal to null TcpStream factory has no connections, no configured connections. Okay, let's wait for the test to fail and then we make it green. What? TcpStream factory? 931? Oh, giveaway time. One nano for it's rigged, guys. It is. The wheel is rigged. I'm going to look for a different wheel. Sending. So. Expect error in TcpStream factory RS. TcpStream factory. Oh, maybe I didn't save all files. Let's try again. LFLF, thanks so much. Yeah, sure. There you go. Line 31? There is no expect error here. What's wrong here? Oh, I think this now we have the right output here. So we have two failing tests. We have the count subnetwork connections test, which fails, yeah, because we have not implemented the create null functionality yet, and the can be nulled function, the can be null test fails for the very same reason. So let's implement create null. It says congratulations, and Sergio says it's a tie. Is it a tie between UNDEF null and LFLF? How many more nanos can we give away? Just one. And how late is it? Oh, okay. It's getting late. I want to, yeah, come to a state where I can commit, and then I want to end the stream. Create null, create null. So here we have to return self, basically, but that doesn't do the trick, because we have to make this part here nullable. And now we do that in the very same style like last stream with TCP, with the TCP stream. So we have our TCP stream factory, and like that. So now we have to introduce a trait, internal TCP stream factory. And this one delegates to the trait. Trait. And then we have two implementations. Oh, that one. We have two implementations. We have a TCP stream factory stub, or we can also start with a null. Which does not do anything. So this is one implementation, and then we have the real implementation, which we call TCP stream wrapper, for example, and that will use the Tokyo TCP stream to create a stream. So this will basically just call connect. Maybe we can add it into this diagram. So this will just call connect on the Tokyo TCP stream. So this is what we have to do to make it nullable. Yeah. So we have just a couple of more minutes, so this will not get finished in this stream, but let's try. So we need a trait. We need a trait called internal TCP stream factory, and it has just the same connect. Oh, we can't use generics in the here, and it is async, so we have to say async trait. So let's not use generics, and let's say it is a socket address, maybe. And it returns that one. And pub, yes, pub is too much, shouldn't be there. Cannot find attribute async trait, so let's import async trait. Okay, and now we create our two implementations of the trait. We have the struct null TCP stream factory, and that implements internal TCP stream factory. And ooh, oh no, I have to also say async trait here. So now let's implement it. Oh, let's implement it now. What's wrong? Why can't I implement the missing functions now? Oh, sometimes this code completion works and sometimes it doesn't. So async connect. So this should now just return, just simply return an error. What Tokyo IO error. You. Now I want to give different values here. So I want to see that the test fails. I want to test the test. I want to see that the test fails for the right reason. Okay, that is okay. And now let's use the real implementation. And we call this... How did we call it in here? We said TcpStream wrapper. No, let's call it TcpStream factor. TcpStream factory wrapper. I don't know. TcpStream factory wrapper, and this should just call Tokyo IO Tokyo net TcpStream connect with the address. And this is async, so await is missing. Okay, and this has to wrap. So this is the Tokyo stream. And we have to return our TCP stream. Like that. And we need an OK. So are you still following stream? Chat? Because we are done. So if this is... If we can compile now, we are done here. So this TcpStream factory now has to use the wrapper, or the internal, our inner is a box. Then you're still alive. That's good. Boxed in. Internal TcpStream factory. So this has to be a box because we want to use either the stub, the null, or the real instance. So here in the new we say inner is box new TcpStream factory wrapper. And when we say create null, we say inner is box new null TcpStream factory. And in the connect, we then just delegate the call to inner.connect. And we say address to socket. What does this return? Just socket addresses? What does that return? Can we just call into? Oh, wait. What's wrong? Oh, again, we have threading problems. TCP socket facade, Tokyo socket facade. Because, let me see, what has to be sent and sync? I think our internal This one has to be send and sync. And what's wrong here? The trade bound socket address from is not satisfied. What does this? What does this do here? Self internal, self future. How does this work? 2 socket addresses. Okay, let's keep it simpler. Can we say, is there a to socket? Because we don't want to listen on or connect to multiple addresses. Can we just say to? No, into socket, into the socket address. Yeah, okay, this is not implemented for oh man. Okay. I think I want to stop here. Let's undo that. Let's go back to how it was, to socket addresses. What's in the chat? Yeah, LF wants to see if everything compiles. I think we are very close, but I'm just confused with to socket addresses, how to use that. Converts or resolves without blocking to one or more socket address values. And how? But how does it work? To socket addresses. To socket addresses. Implementations on foreign types. And what can you do with it? I don't know. I want to stop here because it's late. I have to go to bed. So let's just do a quick recap. Bob says, it's just amazing how fast you get feedback from your test cases compared to working on the C++ code base where rebuilding all the tests takes minutes. Yeah, so that's also why I really don't like to work on the C++ side because the feedback loop is just way too long. And I even find the feedback loop that I have right now way too long. Because it can take, I don't know, 10 seconds or more for right now to get feedback. And I want to make this even faster in the future because it's not a priority right now because I want to get it to Rust first. But yeah, I think quick feedback loop is very important to being productive. Ed says, good night Ed. Wait 1 second, let's just spin the wheel one last time. And then in the next stream, I wanna get a different wheel. I wanna get a different wheel for the next stream. LF 1 Nano. See ya in a week, guys. It was fun again. Yeah, in 1 week we will continue from here. We will, yeah. In this diagram, we will delete the socket facades. We will move our nullable TCP streams into our channel classes, and then we will, we're going to simplify the message serializer, but a long way until we're there. So it will probably take a couple of streams. So Sergio says, yeah, winner of the day, LFLF. Yeah, so LFLF says, great stream as always, thanks. Next time I definitely will win. No, next time I will pick a different wheel. Okay, guys, it was fun as always. See you next week, same time, same place. 7:30 UTC. Have a great week. See you then. Bye bye.